They are among the biggest explosions of radio energy in the entire universe.
They are among the biggest explosions of radio energy in the entire universe. As we look up at the sun, we are reminded of the immense power and energy that it radiates across our solar system. It's hard to think about something that could beat our sun, yet beyond our own star lies a cosmic wonder that makes even the mightiest of solar giants seem small. Betelgeuse, a massive red supergiant star with its immense diameter, irregular pulsations, and unpredictable behavior, defies easy explanation, leaving scientists in awe of its power and potential. While studying this magnificent star, they've landed on something terrifying. Join us as we dig deeper into what the James Webb Telescope just found and how it might change everything. Most people don't know this, but you can actually see Betelgeuse in the sky if you're looking up at the night sky during the winter months in the northern hemisphere. You can't miss it. Just take a peek at the constellation Orion, and you'll spot it as the reddish-orange star that marks the upper left corner of the constellation's rectangular shape. It's one of the largest and brightest stars in the night sky, so it's hard to miss. But if you've ever really noticed it, you know that the star doesn't actually stay constant. While at its peak it's one of the brightest stars, sometimes it loses a bit of its sparkle. That's not just happenstance. You see, while to us from here it just looks like another star, it's not. First of all, it's over 640 light-years away from us. Now, that might not seem like a lot at first glance, but it's a huge distance. In fact, if you were to travel at the speed of light, which unfortunately we can't, it would still take you over 640 years to reach Betelgeuse. And if you wanted to travel there in a spacecraft, even our fastest ones would take over 12 million years to get there. That's longer than the entire history of human civilization on Earth. But distance isn't the reason why the light changes all the time. Betelgeuse is what we call a pulsating red supergiant, which basically means that it's a big old star that expands and contracts, and when it does, it can get brighter or dimmer in the night sky. The changes in brightness can happen over a long period of time, anywhere from tens to hundreds of days. What's even crazier is that Betelgeuse can vary in brightness from almost plus 0.5 to as bright as magnitude 0. That's a pretty big range. These changes happen in cycles, with the shortest one being 185 days and the longest being 2,335 days. Sometimes Betelgeuse can get really dim. This is what we call a V-band magnitude, and in February 2021, it was reported to have its lowest V-band magnitude in a while, which was a magnitude of plus 1.92.66. That's still pretty bright, but it's definitely dimmer than what we're used to seeing from Betelgeuse. But brightness isn't the only thing it's known for. Betelgeuse's distinctive reddish color is due to its cool surface temperature of around 3,500 Kelvin, which is much cooler than our Sun's surface temperature of 5,500 Kelvin. This lower temperature also means that Betelgeuse emits much less energy per unit of surface area than the Sun, which is why it appears much dimmer despite being one of the largest stars known to us. It's like the giant who's happy to be Loki and doesn't need to show off their size to feel important. But don't let Betelgeuse's laid-back nature fool you. It's still a supergiant star that's around 20 times more massive than our Sun. That's partly the reason why the star is so well studied. You see, Betelgeuse has been a prominent object in the night sky for centuries. It was first identified by the ancient Greek astronomer Ptolemy, and its Arabic name means the armpit of Orion. And while back when it was named there was only so much you could know about it, modern telescopes have allowed researchers to study this phenomenon in greater detail. By analyzing the light emitted by Betelgeuse, astronomers have been able to determine many of its properties, such as its size, temperature, and composition. The Hubble Space Telescope has provided detailed images of Betelgeuse's surface, revealing intricate patterns of gas and dust. These observations have allowed researchers to create models of the star's behavior and predict its future evolution. Betelgeuse has also been studied using the Atacama Large Millimeter/Submillimeter Array, ALMA, a cutting-edge observatory in Chile. ALMA has provided high-resolution images of Betelgeuse's surface, revealing new details about the star's structure and behavior. One of the most exciting discoveries made using ALMA is the presence of a vast plume of gas extending from the star's surface. This plume, which is thought to be caused by Betelgeuse's pulsations, may help explain the star's unusual behavior and how it's changing all the time. Betelgeuse's pulsations are caused by a process called convection, in which hot gas rises and cooler gas sinks. This motion creates waves that travel through the star's atmosphere, causing it to expand and contract. With the Hubble Space Telescope, we've got detailed images of Betelgeuse's surface, revealing intricate patterns of gas and dust. These observations have allowed researchers to create models of the star's behavior to figure out how it might behave in the future. Betelgeuse's surface is also covered in dark spots, also known as star spots or magnetic spots, which are areas on the surface of the star where the magnetic field is particularly strong. These regions are cooler than the surrounding gas because the magnetic field inhibits the flow of hot gas from the star's interior to its surface. This creates a sort of cooling effect that makes the spots appear darker than the surrounding gas. The magnetic field on Betelgeuse is believed to be several thousand times stronger than the magnetic field on the Sun. This strong magnetic field causes gas on the surface of the star to become trapped in loops or arcs, creating regions of intense magnetic activity that are visible as dark spots. The presence of star spots is not unique to Betelgeuse. Many stars, including our own Sun, have them. However, the star spots on Betelgeuse are particularly interesting because they are much larger and more numerous than those on the Sun. The spots on Betelgeuse can be several times the size of Earth and cover up to 20% of the star's surface. The presence of star spots can also affect a star's brightness and cause it to vary over time. This is because the spots are cooler and therefore emit less light than the surrounding gas. As the star rotates, the spots move in and out of view, causing the overall brightness of the star to fluctuate. In the case of Betelgeuse, the star's pulsations also play a role in its brightness variations. As the star expands and contracts, the spots can move in and out of view, further contributing to the star's variability. One of the craziest things is that Betelgeuse isn't as one of a kind as you might think. There may not be many stars exactly like it, but there are some that share some similarities and are just as fascinating. One of Betelgeuse's cosmic cousins is Antares, a red supergiant located in the Scorpius constellation. Antares is also a variable star, meaning it changes its brightness over time like Betelgeuse. Antares is massive, about 12 times more massive than the Sun, and has a radius that's about 700 times larger than the Sun, so it's pretty safe to say that Antares is no shrinking violet. Another star that's often compared to Betelgeuse is Mu Cephei, also known as the Garnet Star, located in the Cepheus constellation. Mu Cephei is one of the largest known stars in the universe, with a radius that's about 1,650 times larger than the Sun. Like Betelgeuse and Antares, Mu Cephei is a variable star and is one of the brightest stars in the Milky Way galaxy. Although Betelgeuse is unique in its own way, these stars are equally intriguing in their own right. Each star has its own set of properties and characteristics that make it distinct, and it's fascinating to study them all and compare their differences. To explain the difference, we're going to be using our Sun as the point of comparison because that's something we all know plenty about. While Betelgeuse, Antares, and Mu Cephei are all red supergiant stars, they each have their own unique properties and characteristics that set them apart from one another. One of the main differences between the three stars is their size. Betelgeuse, for example, has a radius of about 1,000 times that of the Sun, while Antares has a radius of about 700 times that of the Sun. Mu Cephei, on the other hand, is even larger, with a radius of about 1,650 times that of the Sun. Another difference between the three stars is their brightness. Betelgeuse is one of the brightest stars in the night sky, with an apparent magnitude that varies between 0.0 and 1.3. Antares fluctuates in the same general range too, but can get slightly brighter at times. Mu Cephei is much brighter though, with an apparent magnitude that varies between 3.4 and 5.1. The stars also differ in their mass. Betelgeuse is estimated to have a mass of about 11 times that of the Sun, while Antares is thought to have a mass of about 12 times that of the Sun, making them around the same size and brightness. Mu Cephei, however, is much more massive, with a mass estimated to be around 20 times that of the Sun. Finally, each star has its own unique set of properties and behavior. Betelgeuse, as we've discussed earlier, is known for its pulsations, which cause its brightness to vary over time. Antares, on the other hand, is surrounded by a massive cloud of gas and dust, which may help explain its unusual behavior. Even though it's technically brighter than Betelgeuse, the dust and clouds around it keep it from appearing as bright. Mu Cephei, meanwhile, is known for its extreme luminosity, which makes it one of the brightest stars in the galaxy, but it's not as volatile as Betelgeuse. While we've mentioned the pulsations, the color, and the overall behavior of the star already, there's one thing that all of that ends up meaning. It's that a supernova is imminent, and it might be coming up fast. Now, when you first hear of it, a supernova sounds glorious, and in a way it is. But when you really begin to understand it, it's terrifying. Supernovas are incredibly powerful explosions that occur when certain types of stars reach the end of their lives. These explosions release huge amounts of energy, creating some of the brightest and most energetic events in the universe. There are two main types of supernovas, Type 1 and Type 2. Type 1 supernovas occur when a white dwarf star, which is the dense remnant of a low-mass star, accretes matter from a companion star until it reaches a critical mass. This triggers a runaway nuclear fusion reaction that causes the star to explode. The star is always on borrowed time, and when it explodes, it causes a lot of mayhem, but nothing compared to what happens with Type 2. Type 2 supernovas occur when a high-mass star runs out of fuel and can no longer generate the nuclear reactions that support its structure. This causes the star to collapse in on itself, and then rebound in a massive explosion. When a supernova occurs, it releases an enormous amount of energy in the form of light, heat, and radiation, taking everything in its path along with it. The explosion can be so bright that it outshines the entire galaxy that the star is located in. This brightness is temporary, however, and the supernova will eventually fade away over time, usually a few weeks or at most a few months. The explosion of a supernova also creates a lot of heavy elements, such as iron, nickel, and gold. These elements are created through the process of nucleosynthesis, which occurs during the intense heat and pressure of the explosion. All of the elements are then scattered into space, where they can be incorporated into future generations of stars and planets. So, it's kind of like one star dies to make space for the ones that come in the future. But this isn't just by leaving elements behind, because we all know that it takes a lot for a star to be born. The shock wave from a supernova can actually trigger the formation of new stars and can even compress nearby gas and dust clouds enough to trigger the formation of planets too. Supernovas are also important for cosmology, as they provide a way to measure the distance to galaxies that are just too far away to measure using other methods. This is because supernovas have a consistent peak brightness, which allows astronomers to use them as standard candles to measure distances. Supernovas are also particularly beautiful. The expanding cloud of gas and dust that is created by the explosion can take on a variety of shapes and colors depending on the type of supernova and the environment it's in. But the thing is, even though they're visually appealing, they're incredibly dangerous. One of the primary dangers of supernovas is the release of high-energy radiation. When a supernova occurs, it releases a burst of gamma-ray radiation that can be thousands of times more powerful than the energy emitted by our Sun in its entire lifetime. This radiation can be deadly to life on Earth. It's so powerful that it can literally damage DNA and other biological molecules and break down the building blocks of life as we know it. There's also the potential for a massive blast wave. When a supernova explodes, it creates a shock wave that can travel through space at incredible speeds, potentially colliding with other objects in its path. The same ones that lead the way for new stars and planets to be born can also do the opposite. If a supernova were to occur nearby, this blast wave could potentially cause significant damage to the Earth's atmosphere and even cause mass extinctions. Researchers are divided about when Betelgeuse might go supernova. Some say it's just about to happen, while others claim that it could be tens of thousands of years away. But considering the dimming is at the level that it is, chances are the cosmic event might be much closer than we'd want it to be. While the Earth is at a comfortable distance away from the star, With events like this, you never really know how crazy things might get. Could the Betelgeuse supernova take the Earth along with it?